अच्छा तो ये वही क्वेश्चंस हैं, ठीक है. बॉन्ड्स ब्रोकन माइनस बॉन्ड्स फॉर्म्ड, ठीक है. रिएक्टेंट्स में बॉन्ड्स यू गोना ब्रेक दोस बॉन्ड्स, और प्रोडक्ट के अंदर यू गोना फॉर्म बॉन्ड्स, ठीक है. तो अगर तो बॉन्ड एनर्जी दिस इज ये, ठीक है. अच्छा, so this one, we're going to start with this one. I'm going to do more questions similar to this. Worksheet sent की थी. I think I did not send the worksheet. I'll send this at the end. Okay. So I'll do another one. He's saying a reaction which causes the presence of. So there's a reaction. Okay. This is the reaction, and they've given the enthalpy change. What he's asking is, what is the bond energy in kilojoules of the bond between the atoms in NO? So NO ke bonds. Now, this reaction, okay, this entire reaction has this enthalpy change. So how do you calculate enthalpy change bonds broken? So how many bonds are broken? You're breaking the N triple bond N and O double bond O. So 2 bonds are broken. N triple bond N and O double bond O. ये positive होगा, ठीक है. They would have a positive sign. Why? Because it's endothermic, ठीक है, bonds breaking. ठीक है, so that this is bonds breaking, and then bonds formed. How many bonds are formed? 2 of them between N and O. So 2 NO bonds are formed. Now the enthalpy change will be equal to 180. So the answer is given already. The enthalpy change is 180. And he's asking you to figure out the bond energy of NO. The N triple bond N, that's given in the data booklet. If you open the data booklet over here, so N triple bond N is given over here. That's 944. That one is given. So you get that's 944. O double bond O is also given. That's 496, I think. Yeah, that's given 496 plus. Keep your calculators with you, okay? And minus 2NO. So I want to figure out the bond energy of NO. That's X, and that's plus 180. Okay, so try and figure out what the answer is going to be. It's going to be 944 plus 496. Bring the 180 to this side. That's minus 180. 2x on the other side. Get the 2 to the other side now. So what are we going to get? So answer without care. What's the answer to this? And the answer is not going to be 630. You're getting 630 kilojoules per mole. The closest one is A. So now there's going to be a reason why sometimes the answers are not going to be exact. The reason is it's this data booklet. Every year this data booklet gets published, and every year it has some minor changes. Values these values are made more accurate, or sometimes there would be some slight changes in this. So which is why remember this, sometimes when you're solving MCQs, you're not going to get the exact answer because that's an older question. So the data booklet values would be different in this year. Clear?
Yes, sir.
Similarly, this one, which bond in the structure below has the lowest bond energy? So let me add one point about bond energies, okay? And that point is, which bond do you think is the strongest? Which one requires more energy? Like, how do you figure out if bond is strong or weak? Any idea?
The more energy required to break the bond.
But like so what are the factors on which bond strength might depend?
Electronegativity.
Not electronegativity, it's first one. If you have a single bond and a double bond and a triple bond, who's stronger?
Triple bond.
Yeah, so remember one thing, that you've got more shared electrons, there's going to be more attraction. Okay, so one thing you have to remember is that So more bond strength, more bond energy. So I mean, it's obvious triple bonds are stronger, right? So so you're going to have, so for this you're going to have higher. So you're going to have higher bond energy and more bond strength will be added. Any other factor, like if you have, so bond strength increases, right? As any other factor, let's say I give you another option, like you've got 8s here and HBr and so on, HI. So who do you think has the strongest bond between these three?
HI.
The bigger atoms, remember, have weaker bonds. ठीक है अभी ये ना हम बाद में डिस्कस भी करेंगे केमिकल बॉन्डिंग में ठीक है reason we're dealing with bond strength, so I want to discuss this over here as well. Just remember as a rule that I'm not going to go into the details right now because we're going to study this in a lot more detail in chemical bonding. Just remember the rule that bigger atoms form weaker bonds, and there's an obvious reason for that. Okay, if the atom is really big, okay, let's say iodine is really big and hydrogen is this tiny atom, right? And so this one. So if you have a big atom, big atoms would be very far away from each other. I mean, the nucleus would be very far away, this nucleus over here, and there's a shared electron over here. So the distance between the nucleus and the shared electrons increases. I mean, the electrons, if you have a bigger atom, bigger atoms are always very far away from each other. Is that clear? So if distance zyada hoga, the attraction between the nucleus and the shared electrons would also be greater. Do you get this point? Is this clear to everyone?
Yes, sir.
Okay. And if you have a smaller atom, right, really small atoms, then what happens is that the atoms are like really close to each other. So if they are shared electrons, so वो जो shared electrons है ना, they would be very close to the nucleus, right? So there's going to be very strong mutual attraction for those. Remember, in a chemical bond, if you already, I mean, you should already know this, that in a covalent bond, the reason the atoms are together is that the two nucleuses are attracted to the shared electrons. So there's a mutual force of attraction. This nucleus is getting attracted to the shared electrons. This nucleus is also getting attracted to the shared electron. लेकिन वो जो force of attraction है ना, that is inversely proportional to the distance. If the further you are, the weaker the attraction, right? So remember this, that smaller atoms, they always form stronger bonds, and bigger atoms, they always form. And it's not even about the type of bonding. You can have ionic bonds, and this would still apply. Okay, ionic bonding में क्या होता है? In ionic bonding, what you have is you've got two ions, right? You got a positive ion, you got a negative ion, right? Now, the bigger the ion, the further away they are going to be from each other. The smaller the ion, the closer they are. Like if I make the same ion smaller to each other, now the distance has decreased. The charge is the same, but the distance is now, I mean, they're like really close to each other, right? So they'll be strongly attracted to each other. The idea clear? Just the idea that remember, bigger atoms, they always form, they're always going to form weaker bonds. Is that clear?
Yes, sir.
South clear? Rafi?
Yes. Yes, sir.
So just remember this fact. Baki, we'll discuss this in a lot more detail when we study chemical bonding. Now, coming back to this, which bond in the structure below has the lowest bond energy? Okay. So lowest means strong bond or weak bond? Lowest would be like it easily breaks. It's a weak bond, right? So bond energy, look at the data booklet, the CH bond energy. What is the CH bond energy? That's CH. It's given over here. That's 410, right? Over here. Just so A is 410. B is the carbon-carbon bond. You can have a look at the data booklet. Carbon-carbon bond that's given as 350. This one is 350. You got the CCl bond, which is also given over here. That's 340. Okay, so that one is 340. And the CF bond is not given in the data booklet. So first thing is, now this option C is missing. You don't know what this is. This is not given in the data booklet. CF bond is yahan pe dekh below. It's not there. CF is not there. So that bond is missing. So first thing, out of the three, which one is the lowest one? It's CCl, right? So A and B are not the options, right? It's going to be CCl. Ab in dono ka CF or CCl, which one is stronger? CF or CCl?
CF.
You can remember F is a smaller atom, so it's going to be stronger, right? So it's going to have a higher bond energy. Okay, and the reason is that fluorine is a smaller atom, so it has a stronger bond. Compared to CCl. So this one, what is the bond energy of the NF bond? How would you calculate this? How many bonds are broken and how many bonds are formed in this reaction? The overall enthalpy
So in
change.
which side?
Huh?
In which side?
कौन सा?
Sir, कौन सी side में?
Hey, देखो, bonds broken is always the reactant bonds are broken, right? Formed are on the product side.
Okay, sir.
So,
So what if it's a reversible reaction? Then?
remember, enthalpy change is given for the forward reaction. Okay.
Okay.
If the so it depends. The reverse होगा ना, the opposite direction. It would have exactly the same sign, same value. The sign would be different. क्योंकि जब आप reverse पे जाओगे ना, what will happen is that the bonds that you broke are now being formed, and the bonds you formed are now being broken in the reverse direction. So it has the exact same value, but it has the opposite sign. Okay, clear?
Yes, sir.
So, but remember, a reaction, whenever enthalpy change is written, it's usually for the forward one. The backward reaction just has the same value except the opposite sign. Actually, in this case, how many bonds are broken?
6.
Okay, so you got 6 NF bonds being broken, and they're going to have a positive sign. How many bonds are formed? Like, how many bonds are being formed in this reaction? Are there any bonds being formed?
4.
There are no bonds being formed. These are 2 nitrogen atoms, these are 6 fluorine atoms. Okay, so no bonds are formed. 0. Okay, remember bonds broken, that's the reactant bonds you're going to break. Formed are going to be whatever bonds are formed in the product side. Over here, no bond is formed. They're not forming, they're just fluorine atoms, 6 of them and 2 nitrogen atoms. So the overall enthalpy change would be 1668. So what is the NF bond energy? It's going to come out to be 1668 divided by 6. So what do we get?
278.
So plus 278. I said, remember this fact that bond energy, although it's always going to come out to be positive, but also remember this fact that bond energy is always a positive value. By definition, bond energy is the energy that is needed to break bonds, right? So it's an endothermic process. So we missed one question, which was slightly harder. यहाँ पे वो कह रहा है, which process could be used to calculate the bond energy for the covalent bond XY by dividing its delta H by N? Now read the statement. Okay, the bond energy for the covalent bond XY, right? So the bond energy for XY is equal to, if you divide delta H by N, so it's equal to that. So he's looking for this expression. Okay, out of all these reactions, in which process would the bond energy be equal to this expression? Starting with the first question, how do you calculate enthalpy change? Bonds broken minus bonds formed, right? So tell me, how many bonds are formed in this reaction? How many bonds are broken in this reaction?
N
N
bonds.
bonds.
Okay, and how many bonds are formed in this reaction?
0.
Okay, 0, because there's just
No.
no bonds formed, right? And you can remember this, K, N is the number of bonds broken, right? Because if I write an actual equation like CH4 turning into 1 carbon and 4 hydrogen, so N over here has a value of 4, right? So how many bonds are broken? That's 4 CH bonds, right? So यहाँ पे how many bonds are broken? That's N bonds of XY. And how many are formed? No bonds are formed, right? So this equation is very similar to this equation, right? So I'm going to do bonds broken minus formed. So you N bonds of XY are being broken. Either clear na N bonds of XY being broken, right? Okay, I guess CH4 hota, there would be 4 CH bonds being broken, right? If you have XY subscript N, that's N bonds of XY being broken. Is this clear?
Yes.
Yes, sir.
And formed is 0, right? And that's your enthalpy change. So if I rearrange this, what do I get? Enthalpy change, usko divide by N karo, that's your XY bond energy, right? Is this clear?
Yes.
So that is the answer. He was saying, okay, which one has XY bond energy equal to delta H divided by N? So it's this one, it's the first one. But similarly, just for the sake of practice, how many bonds are broken over here in option B?
2N.
Okay. So 2N bonds of XY being broken, right? So if I did option B, right? So N bonds of XY over into 2, so that's 2N bonds of XY. How many bonds are formed in this reaction? Like how many bonds are formed over here?
2N minus 1.
You get 2 into N minus 1, right?
Yes,
2
sir.
times N minus 1 bonds of XY. That's of XY are formed. अब फिर ये YY का भी bond है. Y2, it's a Y2 molecule, so there's one bond of between Y and Y also being formed. So the enthalpy change would be equivalent to all of this. Okay, 2N bonds of XY were broken in the reactants, and then you formed N minus 1 bonds of XY into 2, and then you formed a YY bond as well, right? So that's going to be your expression, but obviously that's not going to give you this. How many bonds are broken? That's N minus 1 bonds of XY. No bonds broken over here. And how many bonds are formed? That's N times XY. बल्कि इसको कर लेते हैं. This one is interesting. C. Like if I do C, So how many bonds are broken? That's n times n minus 1 times xy bond energy. Okay, these are the bonds that are broken. And how many are formed? वो फिर minus n times xy, and that's going to be equal to enthalpy change. So इसके अंदर मुझे बताओ कि what would this simplify to? That's n कट जाएगा because n into x. What would this simplify to? N minus 1. I think it will be what will be left with is minus 1 times xy bond energy. Is that clear?
Yes, sir.
And that's going to be your enthalpy change. So basically, its enthalpy change is equal to minus the bond energy of xy. So the question could have been that as well. So ये बस थोड़ा सा tricky था, but just remember, hopefully clear है ना सारों को, कोई issue नहीं है इसमें.
No, sir.
So what else we've got? अच्छा इस वाले को solve कर लो कि what type of bond do you have in carbon monoxide? Is it a triple bond or a single bond?
So 2 double bond and 1 dative.
So पहले इसकी ना value निकालोगे. What do you get for this? How many bonds are broken? So it's a triple bond, right? That's the first thing. How many bonds are broken in this?
5.
कौन से 5? Remember मैंने कहा था कि carbon triple bond O is, you're going to think of this as one thing, ठीक है? So one of that is broken and 2 HH are broken, right?
Yes, sir. So 3.
Or CH3OH. How many are formed? That's your product.
5.
So that's 3CH. Here 1 CO. And there's one OH. So try and calculate this. This is positive, this is negative. Okay, so that's 1077. 2 HH is 2 times 436 minus 3 times CH. 3 times 410. CO, that's minus 360. And then OH, that's minus 460. And that's your enthalpy change. क्या आ गया इसका?
BR.
B?
Minus 101.
So this one as well. Tell me what's happening here in this reaction. He's asking for the bond energy of the XX bond. So there's a gaseous, there's a metal, non-metal X, right? So how many bonds are broken?
None.
0.
ठीक है, और formed कितने हैं? H2H6. Remember, H only makes one bond, so ये वो alkane वाला formula होगा. It's going to be X. So it's this one, right? So 0 bonds broken. How many are formed? There's one X bond and 6 XH bonds, right? So one of the values given, that's 395 for this one. That's answer be given, and that's minus 2775 plus 6 times 395, and you're left with minus XX on this side. तो क्या बना?
D.
D.
Yes, sir. No,
Check कर लो D.
sir, I'm getting A.
नहीं, first thing it's going to be D क्योंकि you did this right. You minus sign. You have to get rid of the minus sign as well.
Oh, yes, okay, sorry.
ठीक है. Plus, also remember bond energy is always positive. I mean, even if you mess up the calculation, remember that. I mean, if you do the calculation correctly, it's always going to be bond energy. If you're trying to calculate bond energy, it's always going to be a positive value. Okay, but one way to figure out that you've messed things up is that you're getting a negative value. Okay, you कुछ tips हैं, just keep this in mind that bond energy could never be negative. If you're getting negative, then that means something is wrong with your working. So it's kind of the working was right. The negative sign would go away automatically, right? That's this one. Okay, there's a. He's saying what is the order of the enthalpy changes for these reactions? Values बताते जाओ. What's the value for the first one? The bond energies are given over here. What's the enthalpy change for this? The first one. Broken minus formed. So what's the enthalpy change?
193.
Okay, it's going to be plus 193, right? Because only the Bia bond is broken, nothing is formed. So what's the enthalpy change for this reaction?
Minus 244.
Yeah, because broken is 0, bonds broken minus formed. Formed is CLCL, that's minus 244. So what about the third one? So you can either break all the bonds in the reactants and make all the bonds in the products. Okay, I'll do one. Like how many bonds are broken? That's 3 CH bonds, right? They're broken. And how many bonds are formed? That's 3 CH and 1 CCl bond. I said the one way to do the bonds broken minus bonds formed thing is you can either break all the bonds and form all the bonds. Like in sometimes it's very obvious that I mean there's no point writing the CH bonds because they're getting broken, they're getting formed again. So these two things will cancel out, right? Equation देख के नजर आ रहा है. Okay, if you look at the equation, you'll see that it's fairly obvious that the whole reaction there's only one bond getting formed, which is the carbon getting bonded to Cl, right? That's the overall thing that's happening. Is that clear? So,
Yes.
Yes,
so just remember, just to save time, sometimes, I mean, the best way is basically if you break all the bonds in the reactants and then form all the bonds in the products. But sometimes it's very obvious that, I mean, you can't obviously, if you try to do this for this reaction, it could get confusing. I mean, it could get very confusing in this. Well, you're actually breaking all the bonds and forming all the bonds from scratch, right? But in some reactions like these, just save time. I mean, it's pretty obvious that the whole reaction, there's only a carbon Cl bond getting formed. So what's the enthalpy change?
minus 340.
This is minus 340 or last one. What's the enthalpy change for the last one?
Plus 410.
Plus 410. Okay, because
Yes, sir.
in the whole reaction, only a CH bond is being broken, right? So plus 410. So what's the order from the most negative to most positive? So what's the order?
Sir, C.
Okay, so there's only one option that's starting with R, so it's going to be C. बस ठीक है ये worksheet तो we're done with this. maybe a few questions. Maybe done with most of it. Done with all of it. So this is just a brief intro of this very small subtopic. So, or Sangana, you did questions in IGCSE and O levels as well, right? We're going to move
Yes.
to the next one. Next subtopic of the same chapter, right? We're still on the same chapter. The Pella part, that's easy. There's going to be one certain section that's going to be slightly harder in relative terms. Not in relative terms, in absolute terms, it's very difficult. Formula wala part, that's usually very easy. Okay, so they're like 4 or 5 formulas, but there's one of them which is very hard to actually solve. So moving to the next one for calculating energy. So next part is about writing definitions. So enthalpy change, delta H definitions. Now starting with, when you refer to enthalpy change, I'm going to start with the first one. I'll first explain why labels are essential. Like, why do you label things? From now on, the enthalpy change would have certain labels. It's going to be called enthalpy change of reaction. Now that means something. It's going to be called enthalpy change of formation. You can have enthalpy change of combustion. And you can also have enthalpy change of neutralization. Now, all these labels, they mean something, because a lot of times it's very hard to actually communicate. Why do you need labels? To make your communication easy. Like when I talk about, when I use the words enthalpy of formation, right, delta HF, that refers to the energy change of a very specific reaction. When I talk about enthalpy change of neutralization, which is written like this, then that refers to the energy change associated with a certain reaction, which is the neutralization reaction. So the communication becomes a lot easier. So with the labels, it becomes easy. Khali enthalpy change mein kahunga na, to the problem would be that no one would be able to understand which enthalpy change am I talking about. But if I use labels, I can be very specific. I can communicate that I'm talking about the enthalpy change of this particular reaction, a neutralization reaction. Delta Hc is enthalpy change of combustion. So if I communicate this to someone, then he would easily understand that I'm talking about the enthalpy change of a reaction that involves combustion. So these labels would be frequently used, and these labels have a certain definition. So I'm going to start off with delta HR, and that's known as the standard enthalpy change of reaction. So standard enthalpy now, when somebody talks about the enthalpy change of reaction or the standard enthalpy, as a first thing, standard. What does standard mean? Standard means standard conditions and standard states. So firstly, it means standard conditions, like whatever you're measuring it under standard conditions. What are standard conditions? 298 Kelvins, which is basically 25 centigrade. Room temperature, basically 1 atmosphere pressure, and if it's a solution, then it's going to be 1 mole per dm cube. Okay, so that is what is meant by standard. It means another thing as well. It also means standard states. Standard states is that the states are going to be very important when you talk about definition. So standard states refers to the state of the substance under these conditions. Like if you're doing the process under these conditions, then the substance will also exist in the state under these conditions. So states are important. Like if the equation or the reaction involves water, water would be in what state under standard conditions? क्या state होती है water के under standard conditions?
Liquid.
It's going to be a liquid. That's known as the standard state of water. Okay, so if somebody is going to ask you, what is the standard state of water? Then that is the state that exists under standard conditions, and that's liquid. So you have to understand what is meant by standard. And when you refer to the standard conditions, this not is used. You've got this not written on top of the enthalpy change. जब भी ये नजर आएगा ना, that means we're dealing with standard conditions. That's what we're dealing with. So that's one thing. Now coming back to the definition. So what is the enthalpy change of reaction? So it's the energy change whether it's given off or taken in of a reaction when equation moles of reactants react and products are produced. So measured under standard conditions. ठीक है, इसको शॉर्ट करके measured under standard conditions. एक मैं इसका ना वो देख लूँ enthalpy ऐसा तो हो गया वो नहीं वो तो ठीक है ठीक है. The energy chain of reaction when equation moles of reactants, reactant products are produced, measured under standard conditions. I said meaning of this thing. Okay, what does that mean? What does that signify? I said, so if you're asked about enthalpy of reaction, remember if I burn something, if I burn methane that's methane gas that's coming in the stove, or if I burn octane, which is petrol, so there's a certain amount of heat produced. That's the enthalpy change. But that is not the enthalpy change of the reaction. Okay, it's the enthalpy change of a certain quantity of reactants that you reacted. Right? Lab mein aap jate ho, so you burn a certain amount of petrol. So let's say this is petrol. There's octane in it. So the equation for petrol burning is liquid. It burns with oxygen and produces carbon dioxide and H2O. So time खत्म हो रहा है, इसको जल्दी से wrap up करें कि you got 8 carbon dioxide, you got 9 H2Os, and I guess you got 25 by 2. So remember, states are very important. Okay, always write when you're dealing with definitions, always write the states. This one is a liquid, right? So coming back to my point, let's say you burn any amount of petrol in the lab. A certain amount of heat is produced. That heat is the enthalpy change, but it is not the enthalpy change of reaction. It will only be considered the enthalpy change of reaction कि अगर ये वाले moles हो, like you burn exactly 1 mole of octane and you reacted with 12.5 molecules of oxygen and 8 moles of carbon dioxide and 9 moles of water produced, right? So if you use the exact same quantities that are given in the equation, then it's called the enthalpy change. Then whatever heat is produced, that is going to be called the enthalpy change of reaction. There's going to be an R written over here. Take the normal enthalpy change. And normal enthalpy change is you can burn any amount of octane and a certain amount of heat is produced. But if you burn exactly 1 mole of octane and a certain amount of heat is produced, then that heat energy is going to be called enthalpy change of reaction. Is that clear?
Yes, sir.
सारों को बात समझ आई है?
Sir, I didn't understand the last point.
Yeah, I'm just saying that. See, you've got octane, right? गाड़ी से पेट्रोल निकाला है, थोड़ा सा you just burnt it, right? And heat is produced. That heat is produced for, let's say, 0.45 moles of octane that you burnt. So that is the enthalpy change of the reaction that you did. But you just use 0.45 moles of octane, right? But the real world, you calculate करके you're not adding 1 moles, right? You can add any, you can use any quantity, right? You increase the quantity, more heat is produced. You decrease the quantity. Remember, with enthalpy changes, you change the quantity, the amount of heat produced is going to change. Am I clear?
Yes, sir.
So a reaction, a particular reaction, can have many different enthalpy changes depending on the quantity that you're using. Octane ज़्यादा डाल दो तो ज़्यादा heat produce होगी, right? So the enthalpy change value will continue to change depending on how much octane you're using, right? So जो खाली enthalpy change है ना, delta H with nothing next to it, right? That could be for any quantity. But when an R is written next to it, then that means that this enthalpy change is specifically for the moles that are given in the equation. You burnt 1 mole of octane, a certain amount of heat is produced, and that heat energy would be called the enthalpy change of reaction. Clear है? बात समझ आई?
Yes, sir.
So you have to be careful about this. Okay, in the exams, there'll be questions. They'll ask you, okay, 0.8 grams of octane was burning, right? Like at the end of the question, they'll ask you about enthalpy change of reaction. So वहाँ पे ना, make sure you keep this in mind, that when he's asking for the enthalpy change of reaction, तो वो उस quantity की enthalpy change नहीं पूछ रहा जो which you're burning in the reaction, right? He's asking specifically for the moles that are given in the equation. उस तरह के questions करेंगे, but just remember, what does enthalpy change of reaction mean? It means that you have to now calculate the enthalpy change for the moles that are given in the equation. You have to stick to it. Okay? You can't just use any quantity, right? Is that clear?
Yes, sir.
चलिए ठीक है, क्वेश्चन नहीं है इसके ऊपर?
No, sir.
चलो ये वर्कशीट में सेंड कर देता हूँ वीकेंड में, ठीक है? ओके एवरीवन.
Okay, sir.